Hi everyone. Brings me great pleasure this week to bring Toni Hatten-Roberts to our weekly Wednesday webinars, and she'll be building on David Moore-Kunis's great presentation last week about the science of learning. And tonight's topic is bridging the gap between cognitive science and classroom practice. Toni is an accomplished classroom teacher, administrator, researcher, and is also a consultant who works with many schools to bring this sort of thing into life. So without any further ado, hand over to Toni. Thank you.
Thanks, Michael, and thanks for taking the time to have a listen tonight. So I guess I wanted to start on where I began on this journey. So I was working with a school a number of years ago, probably 4 or 5 years ago. And this was a school and we'd just begun our journey of implementing explicit instruction and direct instruction as a change for our school to have school improvement. We were looking for evidence-based practices, and so we were drawn to these practices. But at the same time, I was doing a psychology degree, and it was at this time that it became really evident to me that I knew very little, that the things I was learning in cognitive science, I actually knew nothing about as a teacher. And I was quite dumbfounded by my own ignorance, I guess. And at the same time, the instructional changes that we were implementing though in the school when we were using explicit instruction was increasingly making more sense of why those strategies were working. And I guess I began to build a language that could support the strategies in teaching through evidence from the field of cognitive science. So tonight we're going to have a look at these couple of things. So we're going to be looking at identifying how explicit instruction is impacted by science of learning. We're going to identify the connection between explicit instruction and cognitive load theory. We're going to identify some elements of what a term is known as load reduction instruction, right? And just really where does that come from and why have I chosen that? And then identifying in detail a couple of elements of explicit instruction that have research behind them and have a really direct line to science of learning, and that is verbal rehearsal and looking at dual coding in the classroom and what it looks like in a classroom. So I think the research from science of learning has really got a consistent line of evidence that supports the pedagogy that we implement when we're doing explicit or direct and very structured approaches to instruction, particularly for novice learners. And most of our students that we come across in schooling are novice learners in their domain. Yet what's also really evident, and this is my current topic and in my PhD research with the University of Queensland, is this constant battle between theoretical terms, between constructivist instructional approaches and explicit approaches. And that they often create this dichotomous argument of extremes rather than looking at when in the learning sequence or where in the learning sequence and who is it for, as we said before, novice or expert. So to do that, we need really a good understanding of the cognitive processes involved in working memory, because this is what sits behind cognitive science, and it's this understanding of memory and this diagram explaining the information processing model. So these learning theories in memory, and if we think of it in terms, Sweller would say the aim of all instruction is to alter long-term memory, and if nothing's been changed in memory, then nothing's really been learnt. And if we have a look at the little first graphic, the orange one, the incoming information, that's everything that's been delivered by a teacher. That's what we do. We're standing in front of a class or modelling something. We're putting out that information. And it goes into the sensory memory. The sensory memory is spread across two processes. So students are taking it in visually and then auditory. So they're using those two processes to take that information in. However, if there's no attention, if you look at that little next arrow, there's actually nothing going to happen after that. So we might have a great program or we might be delivering a great lesson, but we need to maintain attention. So once we get past that attention, it's going into a student's working memory or short-term memory. And this is where we need some maintenance rehearsal, because if we don't, it can be lost within 20 seconds. So this is where we need encoding strategies in our delivery of lessons. So we need to rehearse the material. Students need to repeat the material. We see a lot of this when we're doing sort of rapid reviews, or we might be doing a warm-up. And we're getting kids to do it. If you wanted to learn something, learn a phone number, you're going to keep repeating it initially just so that you get some sort of trace of memory hung on to in your working memory. The next part of this is encoding for storage, and this is where we need elaborative rehearsal. This elaborative rehearsal is where we start to use things like space learning and retrieval practice, and we want to add meaning to what it is that we put in our working memory. So we activate our prior knowledge, we hook the new information in our working memory to something we may have learnt previously, and that becomes elaborative rehearsal because we're hooking some meaning onto it. And then finally, hopefully it ends up in our long-term memory. However, if you don't touch it for a really long time, and if you don't retrieve it and have effort for retrieval, and this is what we see, and David talked about this last week with spaced learning and space practice, and also, we need some time of forgetting that we actually don't end up with the information in our long-term memory. So we need to keep pulling it back. So do we pull it back the next day, a week later, 2 months later? Previous terms work. Otherwise, we will forget it. So cognitive science tells us that our cognitive limits are reached when there's too many elements are given at once in our working memory. So that's that little orange red box from the last diagram. So we're at greater risk then for information to be misinterpreted or confused, or it's not effectively encoded. Students will then continue to have misconceptions. So we're restricting our students' ability to comprehend if we're not making sure that we're not overloading this working memory. And this working memory really can only hold 4 really new elements at one time. Any more than that, and we start to cause what is really termed cognitive load theory. So cognitive load theory is saying that when we reach our limits, we cause an overload. For many students, that overload not only means that they're going to have confusion and not encode the initial information correctly, but they become disengaged. It goes over their head, and we see this with a lot of older students, and they just don't want to be involved in class anymore. So this is really based on understanding of our working memory, as we stated before, and the science of learning indicates that all students can benefit from the same cognitive strategies because the same cognitive strategies and processes are utilised in memory and memory for learning. So it's evident in the encoding stage, that initial practice, and then it's evident in the effort for retrieval to ensure long-term memory. So effectively, as teachers, we want to use teaching methods that engage cognitive strategies that we know all students will build success from, and these are the cognitive strategies based on memory and not overloading the system. So we really want to reduce the load for students at each part of the learning process. Reduce the load when we present information, reduce the load when we have the first practice, that encoding, when we're learning new information, and then reduce the load with strategies that help them retain the information and make really clear, good connections with what they already know, so that elaborative thinking around the topic. Now, this term load reduction instruction, it's not mine. I didn't think of it, and it's come from some of the research that I'm currently doing at the moment, but I really like the terminology. The words come from Martin, and Martin has a bit of a framework around what does load reduction instruction about. But if you look at those points from 1, 2, 3, 4, and 5, they're quite familiar to us in explicit instruction. They're familiar to schools who have a good handle on gradual release of responsibility. These are things that we would see. But what I like about this terminology is it shifts that focus from explicit instruction as this pedagogical approach, this dichotomous, often seen approach, but it explicitly highlights the need to just reduce the cognitive load demand on students as they learn through the learning processes. So it's really focusing on the why based on how we know students learn from the theories of cognitive load theory and memory. So if you have a look at this, and this is probably a really poor slide, it's an overload. I certainly wouldn't want a slide like this shown to my students. But these little bubbles and this blue map of bubbles is really, if we were to do explicit instruction with fidelity, and fidelity I mean we're doing it really well, these are the instructional techniques and the design ideas that we would want to be effective. So each one of these can trace to a clear evidence-based alignment to managing cognitive load for our students. So if we just look at this one, hopefully it's going to highlight delivering lessons at a brisk pace. We know from the research that it captures attention, that it creates an urgency, and so it focuses students to be engaged. It increases the opportunity for students to respond. Now, we know frequent response is something we would want in an explicit lesson. But when we're using brisk pace, we're going to start asking more questions because we have time to ask more questions, and students get more opportunity to do that verbal response or a written response on the whiteboard. So response cards. They get more time to do corresponding because you're moving more quickly through the material. Just a caveat around brisk pace. So while brisk pace increases attentiveness and the participation, and the study you could look at is Kemp et al., so 1994, think time is particularly important for all students so that they all get to do the thinking, especially when we're still doing a lot of those rapid reviews and we're doing a lot of corresponding at that time. So in that corresponding, we're just asking quick fire questions that we know that all students can answer together. We're just getting them to, it's a practice effect. We're just getting them to repeat it and rehearse it, so recite and recall. We just, even though we're going to speak quickly as a teacher, we just want to give that moment of pause just before all the students say it together, because that reduces the anxiety for students who may have lower levels of working memory or processing delays. We want them all to have an opportunity, and that little moment of think time does that for your students. So this slide is the devil in the detail, because I think as educators, if we're able to articulate the reason why the strategies work, we have a better understanding on how and why to improve learning, because we're basing it on what we know about the importance of memory in learning. We're no longer just associate it with this, oh, we just do explicit instruction because that's the teaching philosophy that our school follows, or this is the lesson framework that we use or we follow, or this is the program that we do. And so we do these things because a program tells us to do these things. It shifts from that being just a strategy or a framework or a template. It shifts from the saying, oh, we're an I do, we do, you do school, or we're an explicit instruction. Yes, I demonstrate and I do an example and then the kids do it. It shifts that. And what it does is makes us focus on, we're teaching to manage cognitive load along the learning process, along the lesson. So the demand of the learning is based on the science tells us about how the brain learns. So it starts to become more about student performance model rather than just an adopted teaching model, because we're really focusing on what the student is doing, how their brain's working, and how then do I as a teacher ensure that I'm reducing the load for all of my students so that they have the optimal opportunity for learning. So as we said before, when a cognitive limit's reached, when there's too many new elements are given at once in working memory, there's a greater risk the information will misinterpreted or confused. It's not going to be effectively encoded. And hopefully many of you know, you've heard this word cognitive load theory before. It's something that's, which is fantastic, certainly more than when I was looking into it, that a lot more teachers know about. And we know that it's a limit in working memory, and that if students get overloaded, that there's going to be a problem in their learning cycle. But what I'd like to introduce you is to probably take that step a little bit further, to know a bit more about what's behind cognitive load theory. So there's three parts of cognitive load theory, and I want to introduce you to the first one. It's the intrinsic load, and it's the demand on the working memory that's related to the actual difficulty level or the complexity of the content, and compared to the current knowledge of the learner. So what are the learners bringing to the lesson, sort of what's in their backpack of knowledge, and so that the complexity of what the new content is going to vary for the student depending on what they already know. So there is a bit of support with the notion that intrinsic load is fixed because it is determined by the student and it's out of our control. But as teachers, we can do something to help this. We can do something to reduce the load of this intrinsic load on the difficulty of the content. And we do this by breaking down the content. So if we break down a multi-element subject matter into really simple, explicit steps, and we teach them in isolation, and then we reintegrate those simple steps to its original complexity, learners are going to be much better able to understand and comprehend that material. So we can chunk the material to assist the schema development. The second part of cognitive load is extraneous load. And this is pretty easy to remember because a little part of that word is extra. So the extra actually means extra stuff that we would do when we're presenting information. So it refers to the unnecessary cognitive processes and working memory demands imposed by the way that we stand up and talk, the way that we deliver, what's on our screen, what's on our whiteboards. and even what we're demonstrating. So what we can do here to manage the load is we want to balance that delivery. We want to balance the delivery around that dual sensory input. So when we looked at that first slide around the information processing, we looked at when we take information, it comes in two sensory modes, and that's our visual and auditory. So what we want to try and do is balance the information across those two sensory input systems and not overload one or the other. And that helps students learn. We can do this by reducing excessive text, so a screen that's just got a whole lot of text on it, or a teacher talk. So teacher talk, too much. So if your teacher's sort of talking 10, 15 minutes before there's any response or engagement with your students, there's an overload for students already, because the students no longer really know what's important anymore. You're not highlighting it for them. We want to remove distractors from what we give. So if we're putting a slide up on a PowerPoint or a lesson, we don't want to have extra information that might actually cause what we would call a split attention effect. Split attention effect can also cause, it's called redundancy in multimedia learning, but a split attention can be caused if you're talking from a slide. So if you're reading word for word on a screen that's got lots and lots and lots of text, and you're reading it, it causes split attention because the students, they start reading, they're then not listening to you, or they're listening to you and you as a teacher aren't highlighting what's important in the text. So we need to minimize too much text and too much teacher talk. The final one in cognitive load theory is this germane load. The germane load is really important because it's the working memory load that we actually want. We need to have some load, we need to have some cognitive demand, otherwise the students are sleeping. But it's essential for learning. So it's the effortful and necessary processing that promotes the development of any sort of cognitive scheme or any content knowledge. But we want to do that while overcoming the intrinsic load that's in the instructional information. So we want to increase it. And the way we can do that is with the learning activities that we choose. It's also the way we deliver the information. So what is the activity that they're involved with? Are we maintaining attention by having the students interact with the content frequently? And we can do that through a number of ways. And rehearsal and retention strategies is what I'm going to talk about next. But the cognitive strategies around that. So how do we rehearse in the beginning, in the encoding stage? And that would mean lots of repetition and lots of verbal rehearsal. And then retention, that would mean using space learning and retrieval practice and interleaving. They're cognitive strategies that help with retention. So the choice of those things is what can impact our lessons. So now I just want to connect that explicit instruction and the science to reduce the load, because these things marry really well together. If you looked at all those bubbles, as I said before, each of those has a line aligned to science of learning. So each load, the intrinsic, extraneous, and germane, needs to be balanced to support the efficient use of working memory so the learning is effective. And so when we're talking about instructional design, and this is where we have lots of command over as a teacher, because we design our lessons, we're talking about the content, but also then the structure of the lesson. So we're going to sequence our skills. How do we do that? The way we sequence, how many steps we break the content down, particularly for novices, and then what we do for experts, that's in our control, and we can manage the students' cognitive load. And then how much scaffolding we give to our students to support the cognitive load while we're doing that. So that would mean organising information for them. So using dual coding, using concrete examples, and elaborative thinking. So elaborative thinking is making sure that students can hook it onto something they've already learnt. So activating prior knowledge, we'd want to make sure that's in our learning sequence. And concrete examples also encourage elaborative thinking. As they move from novice to expert, the elaborative thinking is asking students then more to utilise that, so apply the learning that they're doing. So applying it by thinking about justifying their answers. Tell me how or why that's a simile. Tell me how or why you know that that's a fraction. We can use graphic organisers in our instructional design. We use study guides for retrieval, knowledge organisers. Knowledge organisers are really great for the beginning of a unit because we're going to preload the vocab. We're going to preload some of those bigger concepts that students will need to cover. It's giving them an insight into it. And then really just that basic lesson structure. When we're talking about delivery of a lesson, we're really talking about the way that we stand and present it. What's on our screen? So what's our clear, concise language? What's the material we're going to present? What are we going to hand out to students? It's also about the interaction. So how much verbal response or how much verbal interaction are our students having? The CFU, for those who don't know, that checking for understanding, is very evident in explicit instruction, and we want to be doing it frequently. So we're knowing along the way where our students at in this learning, along the continuum of learning, so we can make adjustments. We can adjust the initial encoding, what sort of activities we choose for repetition, what do we choose for our written examples, using non-examples, and then what do we choose in activities that will enhance retrieval practice. So again, those cognitive strategies, choosing to using space practice strategies, choosing to use interleaving strategies. So if we then go back to our load reduction and instruction delivering strategies, again, all of these things are really evident when we're using explicit, teacher-structured instruction. I just want to focus on now the one we're going to get into today, and that's utilizing dual coding. So what does the research tell us? In dual coding, the processing model of human cognition, both pictures and text are received in the same visual working memory. So we're always at a risk if we overload too much information in that one sensory system. So we give lots of pictures and lots of text, and we get an overload. So we want to spread it out. And this is the thing we're asking about. What's on our whiteboard? What have we got on our walls? What are we handing out? Those sorts of things. So you may have heard, I'm sure you've heard, a picture's worth 1,000 words, and it absolutely is. Pictures are remembered better than words. So if you had pictures alone compared to words alone, the picture is going to be a mnemonic. It's a support. It's a memory support for students to remember concepts. But when we add pictures with words, as long as it's small, it's integrated, and we're not an overload of text, and they're very connected to the learning, then we can have learning enhanced. Even better is when you see narration. So, I'm sure you've all seen a TED Talk. Why is it so effective? Because compared to when text or pictures are presented alone, lots of our studies show that narrated conditions lead to a better performance and less demand on cognitive load on working memory. Because what we're doing is that we're using both channels together. We're using the auditory channel, we're using the visual channel, and we're using them together and not overloading one or the other. But when, as a teacher, we're familiar with using these three. We use pictures, we use text, and we narrate. Our job is to be really careful about keeping that balance. And one of those things is if you do just talk from your screen, if you just have lots of text on your screen and you just present and read from your screen, you actually will cause an overload. It's not an enhanced learning condition. So the way that you stand up and present material can either enhance or it can impede learning. What can happen though sometimes is there is a misuse of pictures, particularly under the guise that it's going to gain attention or it's going to gain interest. Anyway, I'll just give you a minute to have a little read of that. Now, I'm sure some of you may have thought that that was funny, and some of you may have thought that I don't understand. But what I'm trying to show here is that when we actually can risk overloading our students' working memories when we add unnecessary details. In psychology, we would call these seductive details. They're interesting and relevant. Relevant as in the sense that it has the word cognitive load in it. It has some sort of inferencing connection, but it's really not relevant to what I'm trying to explain or teach you today. So it's not necessary for the learning. So it causes an overload, and that becomes where it becomes a split attention effect. Students are focused on the cartoon and not focusing on what it is that they're actually trying to learn. So I'm going to give you a couple of examples of what that can look like in teachers' slides. So here's one here. Now, I know many teachers are really good at using those animation tabs and the controls that make our PowerPoints what we think is a little bit interesting, but they actually become a bit of a distractor for students. So one of the biggest ones I think we need to be mindful of is using GIFs. And we see a lot of GIFs, and I see a lot of GIFs from primary to high school. It doesn't really matter. But these two GIFs, and if you have a look at the one in the right-hand corner, they sort of look like scientists, I guess. And then, they've got some instruments there that might be scientific. And then you've got the ones in the other corner, and they're all hugging. And I'm guessing, and this is my interpretation, that this teacher was saying, well, hey, this is an example where scientists are really happy and they're congratulating each other because they can all communicate, because when we use chemical formulas, the language is the same, and it doesn't matter what language they've got, those formulas actually give a common language, and so they're happy about that. But that's making an assumption that your students make that connection. So unless you've actually made that connection for students, they're not really going to get that. Not all, I'm sure some may. But if we're thinking about opening the doors of learning for every student based on cognitive strategies, this isn't going to help every student. This becomes a distractor. It becomes split attention. They're seductive details. They're not necessary. So we could certainly use some pictures here, but I wouldn't be using a gift. The actual movement of the gift is also a distractor. It's also a split attention effect, let alone the background. It's quite pale. You've got some red writing or blue writing. You've got a mix of font, all those things. So this next one, and this is something to watch for as well, is the dark background, particularly dark, or I see teachers using a lot of black backgrounds because they want to mix it up, and they think, well, the kids have seen white for so long, let's mix it up and have a funky background. But we're sort of choosing to entertain for entertainment's sake rather than focusing on the learning. We need to be careful about the color of a font. So with this screen, I'm not sure what you saw first, but I think for me, I probably saw the red. The red jumped at me first, and that's probably not where I want my students to look first. I probably want them to look at the title. And the other thing was the picture of Keanu Reeves. Doesn't really have much to do with binary numbers. I certainly can see what the teacher's trying to do here. They're trying to set the scene and get a hook, but isn't necessary for this learning. So we just need to be careful with that. The other thing is with this multimedia learning is what we call signaling or highlighting. So if we want to highlight words, so these red words are obviously words that we want our students to remember or use, it's academic language, or they're important, it's better to actually make those elements clearer. So possibly, it was the teacher who would point that out. It would get the students to rehearse that or actually say those words. And here we go again with the funky thing. This next one is, I've just sort of grabbed this from Teachers Pay Teachers, and often we get some really good resources on those things. But if we're putting it on a PowerPoint, we just need to be careful about the overload here. This would typically be for some really young students, so prep or year one. And we've got a lot of red background there, which is a bit of a distractor, the barrier. We've also got the little smiley guys with a pencil and a paper, and the kids are sort of drawn to those pictures. We also have that first sentence. We can put words together to make a sentence, and so those words are red, I'm guessing, because that's the important element. But it would probably be better to have that sentence because that's really what we're saying the learning intent is, to have it on a separate screen. And then on the next screen, have this actual sentence that describes the words. So the words that make up a sentence and why they would make up a sentence. We want to avoid or be careful about having a picture, though, that goes with that sentence. Because for some students, they're not looking at the words, they're looking at the picture. And for them, they're saying the cat is chasing a bird or the cat is climbing a tree. So they're not going to add to this concept of idea of using words or reading words for a sentence. So we just need to be careful about that. Our next slide, again, it's just that it's a font, it's a color issue. There's also a lot of text on that. When students see that, not really sure what's the important element. And this one too. So this is the green and the yellow. We've got a lot of elements. So each little important information, as David talked about last week, as separate elements, put them on a separate slide. Don't have them all on one. Or have them so they would unpack, so that they come out. They've underlined some important things that obviously they want the students to remember, which is okay, but when you're having a look at that, there's a lot of underlining. So it's like, well, which bit's the most important? So by separating these elements, you make it clearer. And finally, I guess, we want a hierarchy of where we want our students to be looking on a screen or on a board. So we want our titles, so that yellow should be bigger than those white titles. So we want to balance the size of our font based on where we want our students to look first. And I certainly don't see the yellow first. When I first look at it, I look at the white, and that we want to be careful about our green and our red and using those colors, because we can disrupt kids who've got any difficulties around color blindness. So we just need to be a bit mindful of our screens, because all these things cause distractors, split attention, they're extraneous load, and they're causing an overload. So in a nutshell, what do we need to do? It's about less is more. So if we're gonna put on a screen, this is the concept from the last one, it'll be settlement, clear definition, and some visuals. Same thing, clear definition and some visuals. The next one, it's a concept development about nouns. It's early in the learning. They haven't really learned about proper nouns or anything at this point. We have a clear definition, we have some visuals, and we have integrated text that matches the visuals. And something like this, for me, because I live on the Gold Coast, it's going to add some meaning, because April's actually in the class, so that's meaning for the students. This is something that the students are familiar with here, and of course I've got this, but we want to have that, we want to add meaning, and meaning needs to be associated with what do they already know, what are the things that they know about. This one here, I just want you to have a look, place your eyes where you think a learner's eyes should be. If you're the little people sitting in front of this easel, you're sitting on the carpet, so you're looking up and you're having to bypass all this information that's on the lower part of the easel. So you've got all these it looks like timetables and possibly some word lists, but all that can create quite a distractor for the students if their learning was meant to be reading or sounding those sentences that are above it. So that's the teaching part, but the students have to battle this overload of visual information from all the other things around it, so all these distractors, and again that causes split attention effect. So even this classroom, there's some dinosaurs there's some animals, they can cause a distractor for some of our students, not all, but for some. So think about, what does your learning space look like? We certainly want to still have posters, and we want to have things in our room, and we want to make our rooms inviting, but what does your learning space look like? We want to make sure that we're not causing a cognitive overload from the visual sensory information, just what's in our classroom. So let's look back. We're going to look at our next topic that I'm going to go into, and that's the ensuring frequent verbal and written responses to interact with the content. And we want to do that frequently. So it's every couple of minutes. We want some sort of verbal or written or some sort of response from our students to know that we're managing attention and that we're keeping them involved and interacting with the learning and also the content. So if we look at this shopping list, and if I wanted you to remember this list but you weren't allowed to take the list, what would you be doing? Now, I'm sure most of you would be reading it, and you'd be repeating it and repeated reading it, because you're trying to rehearse it. So every time we rehearse material, we're trying to get that memory trace in our working memory so that we can actually remember it 20 minutes later when we get to the shop. And most of the studies continue to show that verbal rehearsal assists with memory. So every time you get students to repeat a word, repeat a rule, repeat a definition, or they're actually saying out loud specific vocab that you want them to do, it helps with their memory. And I think intuitively we know as teachers that if we get students to actually verbalize this tier 2 or tier 3, the language, it improves their use of that in their writing. It improves their use of that when they're reading, because if they can't actually pronounce it, they won't remember it. There's quite a bit of other studies around this verbal rehearsal, and I've noted a little bit of those up there, but the attention refreshing and also the active responding, basically the active responding and articulated rehearsal, it's just that repeated rehearsal. And the research really shows that it's an effective learning strategy because it's active. When you ask kids to say something, not just listen or just read silently, when you actually ask them to say something, you're forcing an active response. So you're forcing an active rehearsal. So my research, however, I went a little bit further. So when I was doing psychology in my final honours year in my thesis, I really wanted to investigate this thing that we were doing in my school. So I was already using this verbal rehearsal, but I wanted to look at it to say, was it Is it a learning strategy, and could it mediate extraneous load effects, and could it increase learning? So what was it? What was its relationship with cognitive load? So I was thinking of the verbal rehearsal as an active learning strategy. So that's a germane strategy on the performance of self-efficacy. So what's the effect on cognitive load conditions? And then would it mediate if I added heaps of seductive details? Would being verbalizing actually help that? The study included 104 participants. It was done with adults. It wasn't done with students, just with ethics and working in psychology. It was just much easier to get my study approved. And it looked at 4 different multimedia learning conditions. In multimedia, I really mean as a teacher with a PowerPoint, there's going to be text and there's going to be visuals. And so I was aiming for a low load condition initially for all the 4 learning conditions. So I was narrating and I had a script, so it was the same for every learning condition, so no added extra stuff. And I used visuals, I used images. Now, in the first learning condition, students had to verbally rehearse. They had to rehearse the definitions, the rules, the different things that I was trying to get them to learn. And they were doing that out loud. And in the second condition, they weren't doing that. In the third condition, we had verbal rehearsal, but I didn't add all the extra extraneous load. And I didn't probably mention before, but when I added extraneous load, I added extra, really, like I had some relevant pictures, but I added all this extra information about history or different things like that, pictures, and lots of visuals and lots of text. It had nothing to do with the actual concept I wanted them to learn and nothing to do with what they were going to be assessed on at the end. In the final condition, they had no verbal rehearsal and they didn't have any seductive details. So, as expected, the results indicated by the first bars there, the intrinsic load, that there wasn't really a significant difference in the ratings of this cognitive load, the intrinsic load. Intrinsic load is the least able to be manipulated because it's really relying on the prior knowledge of the students and on the content difficulty. In other words, verbally reciting the information didn't lower how the students thought how difficult this content was. It was typically difficult, the same for everybody. If we have a look though at the next one, the extraneous load, and these were this compared to, so the blue bar compared to the red bar. So the verbal, this indicated that the students who verbally rehearsed reported lower levels of mental effort when they were learning the material. So the lower rating of cognitive load was apparent even though these participants were engaged in activity that could have added to the processing demands, because when you have to speak out loud or repeat a whole sentence or a couple of sentences, you are having a demand on your working memory, but it didn't. In this experiment, the students actually reported a lower rating of their mental effort. Finally, in the final bars, this was the ratings of self-perceived learning. So while it's not a measure of germane load, and there is some, not controversy, but it's been found that that's very difficult to measure. It's a measure of self-efficacy. So these were higher for those who rehearsed the material. So effectively the results in the participants feeling much more positive about their learning by the end of the lesson, the ones who were speaking, compared to the ones who just listened. So the finding would support earlier research that found that learners perceive they're processing information if they feel that they've been more actively engaged. So it's that self-perception. This last little bar graph is really looking at just the complete learning performance, and it didn't differ significantly. And so in psychology, we need a significant difference. So the data needs to actually show a significance, but there was a difference in pre and post, and you can see that on the bar. So see, these two bars don't actually cross, which means we did have a difference. And the difference in these mean scores of the students who repeated compared to those who didn't, who just listened, we had an effect size of 0.04, and it's approaching a medium effect size. But in psychology, I can't report that as being an actual performance increase. So the means don't overlap, and it suggests that it's a positive effect in the condition when the students rehearse. But I think in reflection and looking at the limitation of this study, it looked like it had insufficient sample size to give a definitive answer on this. But it certainly would be something that would mean further investigation. And I think it's important in the research, and I think it's really encouraging that we could have a result. So in summary, as teachers and educators, I think we're able to use the strategies that focus on reducing the load for students. We can improve outcomes for all our students, not just because the research says we should, we should use explicit instruction for novice learners, or we should use teacher-directed, strategies, but because we know and can articulate how students learn based on memory and cognition. And then we make better decisions, instructional decisions based on science. So not just a pedagogy. So these are the three things we looked at. The verbal rehearsal as an active strategy. It ensures that students practice. And the more we do it, the more they're going to get practice. And we know that when students have practice and rehearsal, we're going to lower the cognitive load and we're going to have a better outcome for long-term retention. Students' responses, it facilitates opportunities for them to engage in learning. It's active. It's an actual active thing to do. It reduces the cognitive load. And then finally, we looked at the dual coding. So if we declutter our instructional presentations, we can enhance learning using cognitive strategies of dual coding rather than impede learning just from what we've actually done today. All right, so I just want to wrap up today. So if there's any questions or I can help in any way, just contact me. This is my email that you can contact me directly, or this is my website through which I support schools currently at the moment.
All right, thanks very much, Toni, and thanks for giving up your time tonight and putting together this wonderful presentation. Thanks to all the people who have tuned in. Remember, this will be on our YouTube channel, so you can go on to YouTube, type in Learning Difficulties Australia, and our channel will come up. And you can become a subscriber to that as well, and that is free. And also just remember, if you're not a member of Learning Difficulties Australia, we do accept memberships. It's only $110. It's tax deductible and money well spent. Look forward to next week. We've got Jennifer Buckingham talking about the primary reading pledge. If you're unfamiliar with that, it's on our website, and that will be a wonderful session again next week. But thanks again, Toni, and everyone tonight, and we'll see you next week. Bye-bye.
Thanks. Bye.